Hello everybody, we are dealing with problem number 1.22 if Irodov series. So the problem is stating the velocity of a particle moving in the positive direction of the x-axis varies as v equals alpha root x, where alpha is a positive constant. Assuming that at the moment t equal to 0, the particle was located at the point x equals 0, then find the time dependence of the velocity and the acceleration of the particle, the mean velocity of the particle averaged over the time that the particle takes to cover the first s meters of the path. So now as we start approaching this problem, one thing must be kept in mind that this is a very important equation which is used time and again in different problems. So it is very important that we understand solving this particular expression and many things associated with this particular expression, wherein we have v equals alpha root x, where alpha is a positive constant. Now the another information which is given to us is that at t equal to 0, x equal to 0. So at t equals 0, x equals 0. So from this very first thing we can say that if x is equal to 0, then v is equal to 0. So we can say from here we can say therefore initial velocity, which is at t equal to 0, and hence x equal to 0, so initial velocity is also 0. Now the particle is moving and there is nothing said about acceleration. So the first idea which we have is to solve this problem using the definition aspect. So when I say definition aspect, I mean to say that we have three important expressions. That is, we write A equals dv by dt, and then we write v equals ds by dt. So this is time dependence equation of velocity, wherein we call this as definition. This one is also definition. And the third one which we can say is that if the time dependence is not known, then we can write this as dv by dx, dx by dt, or ds by dt. So this is the chain rule format in which we write the equation of acceleration or the definition of acceleration. So apart from these three expressions, we have three equations of motion which we regard as v equals u plus at, and then we have s equals ut plus half at square, and the last one v square equal to u square plus 2as. So over here it becomes very important and vital for us to understand when we are going to go with the definition and what is the equation of motion and when are we going to use it. So these equations which we regard as equation of motion is applicable when it is known or it is established that acceleration is constant. So this is the condition necessary to apply these three equations. If the condition is not established, then we go with the definition, or we say A equals dv by dt, or v equals ds by dt, or we write A as dv by dx, dx by dt. So this must be kept in mind, and let us start solving the present question which we have. So since over here we don't know if acceleration is constant or not, so we are going to go with the definition. So if we start approaching the problem with the definition, then we can say that we can write v as dx by dt or ds by dt, and this is equal to alpha root x. And since s is equal to x over here in this present context, so we are writing v as dx by dt, and which is equal to alpha root x. And from here we can write that dx upon root x is equal to alpha dt, and now we are integrating both sides. So at t equal to 0, it is already said that the particle is at x equal to 0, and at a time t, we say that the particle underwent a displacement s, or a certain displacement s is covered in the time interval t. So if we solve this particular expression, so we obtain x to the power minus half plus 1, that is x to the power half, and divided by half, or we can say that 2 is up here, and we are writing it from 0 to s, which is equal to alpha t. and hence over here we obtain the term as 2 root s is equal to alpha t, or we can say that the time dependence of displacement s on squaring both sides is equal to alpha square t square by 4. So this is the first answer which we are looking for, where the problem is asking us to write time dependence of velocity and acceleration. So since velocity and acceleration is asked, hence we can say that since s is equal to alpha square t square by 4, so we can write v equals ds by dt, and from here we will obtain alpha square by 4 derivative of t square to t, wherein v equals alpha square t by 2, and a equals dv by dt. So over here dv by dt turns out to be alpha square by 2, which is constant. So over here we have established that acceleration is constant, alpha square by 2, and velocity is proportional to time t. So in case if the question asks us to plot a graph, we can do that also. In many a time inspired questions are made using this particular problem and the particular expression v equals alpha root x, where equations regarding graph plotting is asked. So in that context this problem becomes very important, and this is the A part of the problem which we have solved till now. Now in the second part, the problem is stating to calculate the mean velocity of the particle averaged over the time when the particle takes to cover the first s meters of the path. So first s meters of the path is to be covered, and over here we are asked to calculate the average velocity. So we say since s is equal to alpha square t square by 4, so from here to cover s distance, it will take a time t equals 4s upon alpha square root, that is 2 by alpha root s. It will take this amount of time, and therefore average velocity turns out to be displacement by time t. And over here if we put displacement as s and time t as 2 alpha root s, then over here in terms of the average which we have, so we obtain the value as alpha root s by 2. So this is the average velocity which we are looking for, and the second part of the problem is solved. So over here we have these answers. So if we look at the answers, we have this as velocity expression of time, acceleration which turns out to be constant, and this is the average velocity which the problem is asking us to calculate. So there can be one more method by which we can approach this particular problem. So generally we don't discuss multiple possible solutions, but over here this problem, as I said initially also, that this question is asked repeatedly in many ways. So we are dealing over here and trying to understand what can be the other method to solve this particular problem. So over here in this present context, the equation which we have is v equals alpha root x, and we establish that at t equal to 0, x equal to 0, and hence initial velocity is equal to 0. So if we look at the resemblance of this equation, then we can say that it is resembling the form v square equal to u square plus 2as, wherein if we put v equals 0, we get v square equal to 2as, and v is equal to root over 2a root s. So over here we can say that if we equate this equation with this part, then we can say that therefore alpha is equal to root over 2a, or a can be written as alpha square by 2. So over here we can directly say if there is a resemblance in the two aspects, then we have equated it to this part and then solved it this way, start thinking this way. And since initial velocity is equal to 0, so therefore we can say that v equals u plus at, so at becomes alpha square t by 2, and from here we get the two parts which we are looking for, that this is the two aspects which we have. Now if we calculate the time interval in which this displacement happened, then we will get the B part of the problem as well. So this one is the shorter approach to solve this particular problem. And as I mentioned over here, graph can also be asked. Since acceleration is constant, we can simply draw a line from the y-intercept and draw it straight parallel to the x-axis to get a acceleration constant. And with time velocity is rising, it will again be a straight line graph having a positive slope of alpha square by 2. So this is problem number 1.22, and we have discussed many aspects of this problem apart from the problem itself.